Good morning, 8th grade. Welcome to day 3 of week 5, April 22nd. So today's video is going to be pretty quick. You don't have as much to do today, and it's also a review of something that we already went over in class. So I think it'll be a nice, easy day for you. So the lesson is going over parallel versus perpendicular lines. There's a video here for you to view, just that it goes over the same thing that the lesson goes over, so it's just an additional support if needed. The lesson starts off with having you practice graphing the systems. The first one, they're both in slope-intercept form, y equals mx plus b, so you can just graph as is. The second one, they are both in standard form, so you would have to manipulate the equation to isolate y and then graph them. Okay, the answers are on the following slide, so you'll be able to see those. I then ask you, what do you know about parallel lines? What do you know about perpendicular lines? And there's the same link that I just showed you earlier. So we want to remember that parallel lines, they're always the same distance apart, called equidistant, and they will never meet. Okay, and then perpendicular lines, they are lines that intersect at right angles, 90 degrees to each other. So we've kind of been seeing parallel lines throughout our exploration with graphing, so it should be pretty familiar to you. You have the first one here where you're asked to graph y equals 2x plus 6 and y equals 2x minus 4. So you're going to do the same thing we did. You're going to graph one equation at a time. It's modeled here for you, the first one. So the m, remember, is always the number that's next to the x, so it would be 2. The b is always the number that's by itself, so it would be 6. And if our slope is 2, then that tells us we're going up 2 since it's positive. And we always run to the right 1 since it's a whole number. We can put it over 1. And we're going to begin at 0, 6. So some of you struggled with remembering this yesterday. So just make sure you, maintain that understanding, because it will keep coming up, pulling out the slope and the y-intercept and graphing them. So here's that line graph for you. Then you go on to equation 2, and we do the same thing. So the m again would be 2. The b this time would be negative 4 since it's minus 4. We would move up 2 to the right 1 like before. And now we're going to begin at 0, negative 4. Oh, there's a mistake here. This should say 0, negative 4. Okay? The graph is correct, but that right there should be negative 4. Sorry about that. So here's our red line, and then what do you notice about the two lines? The two lines are parallel, which means that they'll never intersect, so that means there would be no solutions. Okay, like I mentioned, you guys have kind of been seeing this already, so I don't think this is anything new for most of you. So this was just your conclusions. What do you notice about the slopes? What do you notice about the intercepts? And can you come up with a conclusion? So what you should notice about the slopes are that they are the same. What you notice about the intercepts are that they are different. So your conclusion is, if any time the slopes are the same and the y-intercepts are different, there will be parallel lines, which results in no solutions. Okay? Then we go on to the next example, and you have two equations again. So you're going to do the same thing. You're going to identify the m and the b. You're going to graph the line. Then you're going to do the same thing for the second equation, and you'll graph that line. And then I ask you, what do you notice? So in this one, we have intersecting lines, but not only are they intersecting, they're intersecting at a 90-degree angle, which is a right angle. So these lines are special because they form perpendicular lines. So the way we can figure that out is, what do you notice about the slopes? So they kind of look similar. They're the same numbers, but the fraction is flipped around and the sign is the opposite. So we call that negative reciprocals, if you remember talking about that in class. So anytime your slopes are negative reciprocals, which means they're flipped and opposite sign, that's going to produce perpendicular lines. The y-intercepts don't really make a difference, but as soon as those slopes are negative reciprocals, you're going to get perpendicular lines. Okay? The rest of the lesson is just going over negative reciprocals. I have you practice doing a few of them, and then I give you a few examples like we did in class where you identify if the lines are parallel, perpendicular, or neither using those conclusions that we just made. Okay, so remember, for parallel, if the slopes are the same but the intercepts are different, kind of like what we see in this example, then your lines are going to be parallel. Okay, if your slopes are negative reciprocals, which is what we see in this example, the fraction is flipped and it's the opposite sign, then your lines are perpendicular. And then there's a few examples in there where you don't see same slope, different intercepts, and you don't see negative reciprocals. So these lines would be neither. They would be intersecting, but nothing special. They're not parallel or perpendicular. So the answer would be neither here. Okay? And then you're just going to do the same thing for the you do. It's a Google form today. You only have one. So after the lesson, you'll just go to your Google form and you'll complete that. The questions are based on parallel versus perpendicular, and submit. Okay? Tomorrow we are starting something new. We're done reviewing graphing. So if you wanted to get a little head start on what we're going to be doing tomorrow, you can Google solving systems of equations using the substitution method. That's going to be where we're moving. So since today is kind of a light day, if you want to take today to just Google that and maybe look up how it works, maybe look at a few videos, that's going to be where we're moving starting tomorrow. All right, have a great day. Stay safe.